Patrick, if you want to kind of take it away, and if you guys both want to do some quick intros, then we can kind of start diving into the conversation.
Yeah, this will be the first time I take live Q&A in a Twitter Spaces, so please be nice. But we will try to get some people up here. I think it'll make it a lot more fun than just, Steve and I kind of talking about everything. I see Professor Sir is also here. I'm not sure if he wants to hop on as well, or Dr. Sir, I should say.
Yeah, we'll check. We'll check as we go along.
Cool.
But yeah, keep going.
Yeah, so thanks for jumping in, everybody. Really excited to have you here. Great to have you and talk about the HyperSDK, which is an opinionated framework we released yesterday for building virtual machines on Avalanche. Now, before I get into that, I'll give a quick introduction. I'm the head of engineering here at Avalanche, so I work with a team of phenomenally talented folks on building really all things Avalanche. So, we maintain both Avalanche Go as well as the Explorers, Core, APIs, just the bridge to name a few. And we're really excited and interested in the future of Avalanche. My role is just to, help make all that happen and find great people to work with us. And so the obligatory shout out I'll give before we get going is, if you're interested in that vision and collaborating there, please reach out and we could see if there's a spot for you. Stephen, you want to introduce yourself?
Yeah, thanks, Patrick. Yeah, so thanks for having me up here, guys. So my name is Stephen Buttolph. I've been working at Ava Labs for quite some time now, and I think my official title is Chief Protocol Architect, but the thing that I actually do is work on Avalanche Go and kind of lead the platform team with that. So yeah, looking forward to this talk. I don't know necessarily all of the details about the HyperSDK, but I definitely know a lot about Avalanche VMs. So yeah, happy to jump in when I
Yeah,
can.
so I wanted to have Stephen in this chat because the Hyper SDK would not be what it is or where it is without a lot of the work he did over the last few years on Avalanche to make that possible. And so in some ways, the Hyper SDK is really trying to pull out the best parts of Avalanche and make it accessible, just to any developer. And many of those parts and many of the foundations it builds on are, Stephen's work over the last few years. So with that, I think it makes sense to just hop right in. So first off, I'll cover some table stakes, and then I'll talk through a little bit about how you would actually use Hyper SDK or how I think about it. Now, over the next few days, I'll release some video demos you can use if you're not as technical, just to kind of understand what this looks like. And I also am going to be live journaling kind of the experience I have building on and modifying the Hyper SDK and evolving it over time. And so if you want to stay tuned with that, you can follow me. And then I also am basically posting everything with the hashtag HyperSDK journal. So, I'll be just kind of live tweeting different things that come up as I build it. And so if you want to stay tuned, I'll remind you again at the end, but that's the way to do it. So first of all, why HyperSDK? Well, about a year ago or so, we released the first what we'll call like meaningful or like not entirely trivial custom virtual machine as a subnet, and we called that Spaces. And so we created a website called tryspaces.xyz, and it has about 30 validators now. But the whole idea was, can we actually like ship a virtual machine that's entirely of our own creation for people to interact with in some non-trivial way. And so the idea was you could, claim namespaces, put things in those namespaces that other people could, reference. And we got a lot of awesome support from the community on that project. And, it was a great way to really open the door to what people could actually do on Avalanche. But to do that, I had to fork the timestamp VM, which was our very first demo, which is super basic, add a bunch of state management support, a bunch of block definitions, transaction definitions, APIs, everything like that to get it to work. And so while this was fine for like an initial virtual machine demo, when people then asked us, hey, like I want to do my own custom virtual machine, how should I do it? We would recommend to them, hey, like check out the Spaces VM and fork it and use it. Well, when I was building Spaces, I made a couple of very opinionated design decisions that we didn't necessarily expect or want other people to make. But because everything was so tightly coupled and bundled into this virtual machine, it became very hard, especially for someone starting off the first time, to understand what was good to keep and not good to keep. When Avalanche Summit came around a few months later, I decided to fork Spaces and create this thing called BlobVM, which is a little bit more generic version of Spaces. But again, there's a lot of redundant code. I didn't reuse any like common modules that anyone else could use. And it really, again, built a virtual machine from scratch. And so the overhead of maintaining all of this, as well as just understanding the complexity, was a lot to handle. And so to have anyone in the space that wanted to build a custom blockchain runtime go through that every single time they wanted to build a blockchain runtime was pretty onerous for people. And it was clear it was holding back the really the exploration of Avalanche as a place to build interesting blockchain runtimes. And so over maybe the end of summer into the fall, it occurred to me, well, I keep rebuilding virtual machines every time, and I wanted to build a new virtual machine. Instead of just taking the easy path, in quotes, to just copy what I already had and make some small tweaks, I thought, if I was going to be someone that didn't know anything about this, how would I go about it from scratch? And the idea was, like a lot of other projects have considered, is creating some sort of framework that helps you get started much more quickly. But unlike other frameworks, my particular goal with this was performance above all else, which was let's try and make a hyper-specific, hyper-optimized SDK that works to the strengths of Avalanche and then empowers people to launch their own custom runtime if they want to in a few days rather than, a number of months. And so that's what started that effort. And so yesterday, when we released the HyperSDK, I released something called the Index Virtual Machine, which is a way to basically an annotation or context layer on top of decentralized data. Now, that's not too important, but all that matters is that when I was building that, I was building the virtual machine in a way that would make it easy to pull apart in the future. And so after I was happy with that, I then transitioned everything into a separate repository called the HyperSDK. And so that leaves us to really, well, great. So we got to this point, we have this HyperSDK, there's another virtual machine. What does it all mean? Well, the HyperSDK makes it much simpler to build your own blockchain runtime by abstracting away a lot of the core blockchain complexity that you would have to deal with when building your own blockchain from scratch. So those things are things like, implementing the mempool, implementing like the transaction envelope. How do you marshal transactions? How do you sign transactions? How do you manage state? How do you sync that state? How do you have performant gossip? How do you, have performant databases? How do you, really abstract things so that state can be like revertible? All those things are things you'd have to build if you're trying to like make some sort of custom blockchain. But building that from scratch every time is just a huge waste of energy. And so the HyperVM tries to take the best paths, the best like most common use cases, and then put them in a framework that you can more easily build on. And so, what we really want to do here is make it so that anyone that uses the HyperSDK can build their own blockchain runtime and achieve massive scale just out of the box. We felt that if we weren't achieving tens to hundreds of thousands of TPS and allowing people to do that, that it wasn't really particularly interesting for me, because a lot of the questions and conversations we have now are, hey, I want to bring this application with massive scale to the chain, but I can't run it in other places. Like, can you do it? And so for a lot of people that actually are interested in building their runtime, they're doing so for performance, not because they want a slightly different environment to build in. They are doing it because they cannot do it elsewhere. And so the HyperSDK is really about optimizing that and providing that place, but not making it so onerous that you have to like maintain thousands of lines of code and build something from scratch every single time. And so I think the last point I wanted to make here was that this is an open and, going on a continuous process. So anyone that's ever optimized code knows you're never done optimizing code. And so we have achieved, some initial results we think are really promising, but we think with even, some tweaks we've already outlined, continue to increase that performance even further. And so, we're really looking for contributors in both the HyperSDK core, as well as people that are interested in building different virtual machines on top of the HyperSDK to push the limits of the interface. And so that's kind of the brief intro of what this whole project is about. And the reason why we're so excited about it, right, is for Avalanche, subnets are really the scaling path. And if we tried to focus on optimizing just the primary network, we're going to get limited pretty quick on what sort of theoretical throughput and processing power and fees we can provide safely with such a large network. But by going this horizontal scaling approach with subnets, instead of having just one single blockchain where we have 10 or 40 or 150 or whatever thousand TPS, if we can enable every subnet to achieve that kind of scale, the global throughput of the entire network is going to be pretty nuts, especially if things are very tightly coupled with Avalanche warp messaging so that it feels, or you can create a UX that moves data between different regions when you need to. So you're not on some island. And so then the people that really care about some blockchain can execute it without really burdening other people, but more importantly, not theoretically burdening them by having them do a bunch of extra processing. So you can actually separate the processing of the network across as many logical subnets as you can create. So the idea here is, right, if you have 15 hyper SDKs all running at 20,000 TPS, that's 300,000 TPS just on those 10 subnets, and then when needed you can send messages between them. So that's the vision that we're trying to walk, or not really walk but run to as fast as we can, because we think that really is what highlights the strengths of what's going on with Avalanche. But the Hyper SDK is a way to do that without necessarily having to be so reliant on other virtual machines, and giving people the opportunity to start to experiment more on Avalanche as well. So yeah, that's the brief intro. I'll talk about now really the specific aspects of how the Hyper SDK is designed and how you use with it and some of the inspirations behind it. But before I do that, Stephen, I'm not sure if there's anything else you'd want to add, or just to that point. I think that was me talking for about 10 minutes. So
No, yeah, I think that this is just really cool because up to this point, we've really taken a very VM agnostic approach on the platform team. So a lot of our work has been, optimizing some like consensus stuff, or like improving the P chain, or like doing, implementing warp messaging, things like that, which are very like agnostic to what the actual underlying VMs are doing. We basically just kind of provide these very high level functionalities for the VM interface. And so this is really kind of the first solid attempt that we've made to make those abstractions a little bit more user friendly, be able to quickly iterate and get, like, at the end of the day, hopefully, a production ready VM in a relatively short amount of code. Now, I'm definitely not saying the Hyper SDK is production ready yet. It's definitely very like alpha stuff, and we're very quickly iterating on it. But that's kind of the goal, is to be able to get something where you can very quickly iterate on something that is like extremely robust and extremely fast, and is kind of leveraging all of the tech that we've been working on for the past few years. So yeah, I'm excited to kind of keep diving in here. I think that's really all I wanted to say, is this is kind of like a culmination of a lot of things happening. So yeah, really cool.
Cool. Yeah. So at a high level, I think now it makes sense to talk a little bit more about how I wanted people to think about interacting with this thing. And so the way I think about blockchain interaction and blockchain design, and before I go into this, there's about a million ways to approach this issue. So this is my opinion on it. And I think other people have tons of interesting opinions that would be great SDKs on their own. And, if you have after looking at the Hyper SDK, like, well, not how I would have designed it, I would like to design it this way. We're really interested in sponsoring and, kind of furthering the development of SDK stacks on Avalanche, or building virtual machines for different types of use cases. So the way I think about blockchain design, and the reason why I call it an opinionated framework, is I hide everything that's really going on behind something I call actions and authentication. So actions, simply put, are what you do on the chain, right? Like, what does an actual transaction accomplish? In the case of a token transfer thing, like, it would be a transfer. In the case of the index VM, it's about indexing and annotating data. The actions are what make your virtual machine and your runtime unique. it could be as simple as a transfer, or it could be as complex as like running a blob of WASM, like some WASM enabled code that you've uploaded as a smart contract, right? But every action also requires authentication. In a blockchain, you typically can't just like send an action without somehow paying a fee or authorizing the sending of that transaction. Let's just say you sent an action that modified my balance by transferring someone else. You would expect me to authenticate that. Otherwise, you probably have some critical issues here. But the actions, I argue, are fundamentally separate from the authentication. And then the authentication can really be its own type of generic action or generic thing that can then in some way, using state, using whatever inputs you want to provide, authenticate arbitrary activities on chain. And so when you're building, my goal always in the design is to try and make it so that you just have to worry about those two things, actions and authentication. Now, in the index VM, if you want to look at the code for that, and like I said, I'm hoping to produce a number of demonstration videos here in the next few days. The index VM has two types of authentication. One is called direct authentication, and then one is called delegate authentication. So in direct authentication, it's a simple ED 25519 authentication scheme. So you have a public key, you sign that, you verify it, very straightforward. But the delegate one is interesting, and I added it because I wanted to showcase how abstract and generic you can make the authentication, which is you can actually basically set up delegate signers on a single account and have them do scoped activities on your behalf, and or give them all the permissions and delete your previous key so that you can actually maintain a single public key identity even though you are signing with something entirely different behind the scenes. So you may say, practically, why would spending so much time on authentication matter? Well, first off, most people today don't actually store their keys very securely. It's not really a surprise to people, right? So, you may store it in your password manager, you may store it wherever. And I think when LastPass had a hack, a few months ago, a bunch of people complained about, someone just stole my funds. Well, if you were storing things in centralized places, which, not necessarily recommended, but a lot of people do, and then you wanted to rotate your key, you'd have to transfer all your assets, move everything somewhere else. It's a huge burden. It'd be great if behind the scenes you could just change the key that's associated with signing. Another reason is that like as blockchains have grown in scale, bot-based activities are becoming much more common. So, in the case of the index VM, imagine you have some bot that's just like scraping different data sources and just uploading whatever it finds. Ideally, I don't want that bot that has my reputational key to have access to all my funds. Or the ability to just like arbitrarily trash my reputation. So I would prefer to give it very scripted and scoped actions. Now, I'm not saying that to show you the examples to say these are the only two ways. The idea is that I just implemented that in a few days in the index VM. You could implement anything there. You could have it run a ZK circuit. You could have it run some WASM blob to authenticate someone. Whatever you want for your application. You could even have it call out to some external data source if you wanted to and did that carefully. So the idea here is that we want to give the tools and the framework to build whatever you could possibly think of experimenting with. And then by hiding a lot of the complexity of the chain behind the scenes, it should allow you to focus on more of what's important to you and critical for your use case, right? Like if you're trying to build a game, you probably don't want to work on necessarily like the low level transaction serialization. You hope it's efficient, and then you want to work on your gameplay. So the idea is that we can provide really powerful things out of the box without having you get sucked into the underlying chain context. And so when you go through the HyperSDK, you should think about it from those two pillars, actions and authentication. And then everything else you have to do there is really just configuration, right? So you have a Genesis file. The Genesis file has initial rules of the network. And then, these rules, and this is the last really important part about the design, is that actions and authentication, when you launch a network, very clear, right? Like, I launch my network, I want transfers to look like this, I want authentication to look like this. But what we've also seen with working with different subnets is that always changes. So 3 months in, you may learn something, you want a different transaction, you want a different authentication scheme, you want to allow something else, and you want to upgrade your network. And so if you can't upgrade easily, it becomes very error prone and very difficult to actually maintain. And so from day one, actions and authentication are scoped entirely by the validity range in which you can use them. So you can much more easily activate and deactivate different features as the world around you changes. You don't have to like completely reset your chain or abandon it if you want to change something, or fork huge parts of the HyperSDK to actually like modify different pieces. And so actions and auth within the context of time. So you can add actions, remove actions, add auth, remove auth, in a structured way that should enable people to build, hopefully in a much more straightforward way, and that should hopefully really improve the speed at which people can develop, as well as the outcomes that they'll get from the same amount of development time. So. Yeah, I think that's really the how to use it component of the Hyper SDK and the way I think about it. Delving into each one of those more deeply, I think will take this conversation from 45 minutes to an hour to the 3 to 4 hour mark. So I don't think that that's probably a great idea to do right here. But I don't know, Stephen, if there's anything else you want to add on, what's important to you as a blockchain designer aspect. I know, you've been focusing very hard on the primary network concerns, and so this is may not be particularly interesting to you, but or not interesting to you, but like you may not have a lot of thoughts on this yet.
Yeah, I mean, I think that the biggest part around a really nice SDK is the ability to kind of like modify things arbitrarily, right? So like if you have an SDK, like, for example, we could if we like wanted to really go down that route of just really minimizing it. But the thing that I like about how the SDK or the Hyper SDK has kind of been set up is that we've been very aware that people, especially as they dive deeper in, will want to rip things out and kind of implement their own utilities, right? So the Hyper SDK comes with, some mempool functionality out of the box, but if you want to like tweak that to implement your own kind of custom mempool logic to, optimize block gossip, or, include maybe some like, I don't know, like if you want to like go down like the proposer builder separation or something and do like some like MEV route, you could probably do that, right? So I think that that's a very interesting balance here is between like balancing, the kind of how much code you have to write and how like fast it is, and also like how modular and like how well you can like play around with it. So that's something that I'm particularly excited about, like seeing as the Hyper SDK evolves, how that grows out. Yeah.
Yeah, it's really a balance. I think you said it right. Like, if we made it so overly simple you couldn't build what you wanted to, you'd be like, wow, this is easy, but totally useless. And then if we made it so complex, like almost not even having an SDK, it will take so long to get started and you'll have to make a lot more decisions you probably don't care about. So the way I judge SDKs really is like, how does that balance feel? And I think that balance is always pretty opinionated based on what you actually end up building. And I think that's the case here as well. And so before I start taking questions here, Kyle, because I think that'd be a good thing to do next, is that the last thing I'll say related particularly to this is in blockchain, like nothing's really real until the rubber hits the road. And you can talk about ideas and how excited you are about ideas, but until they're actually running in the wild and people can use them, it's an idea. And so very soon in the next few weeks, we're going to start spinning up a number of Hyper SDK dev nets for different virtual machines we have, whether it be the token VM or the index VM, that people should be able to interact with different tooling and everything like that. And so there'll be a huge opportunity to build like cool explorers, cool wallets, what have you for this service. And we really are looking to the community's feedback for, how to improve the Hyper SDK from here. What are really important features we need before it really goes to full production. I think it'll be a lot of fun. So if you're interested in experimenting and exploring and, contributing to what this thing looks like, now's a great time to get involved. And, if you haven't necessarily implemented anything in crypto before, this is a great time to get started. We hope to have, hundreds of different modules within the Hyper VM itself that do all sorts of different things that people can pull off the shelf. And we also hope to version those modules semi-independently, so that people can have different experimental modules mixed with production modules and audited modules, for example. The whole point is just not to get in the not require everyone to fork this SDK accordingly. So as long as you're not changing something core about how the Hyper SDK works and you just want to add like a cool module, for example, WASM, that'd be a really interesting thing to see this SDK become. And then lastly, part two, this SDK is our first real approach at this. It's written in Golang. It reflects a lot of my opinions on how I think you should build a virtual machine. We believe that it's important to offer a lot of different choice to different developers on how they want to actually build their runtime. And so we believe this will be the first of many different SDKs. For example, we're currently working on something equivalent, more for Rust-focused folks. So, if you're Rust and you're like a big Rust fan, you see this, you're like, oh, I guess no Rust for something like this. We will do that. It just so happens that I'm much more experienced at Golang than I am at Rust at this time. So we are very interested in supporting, that kind of building too. Cool. So I think there's a few questions I've found on Twitter I can just go through. I'm not sure, Kevin, Kyle, if you have a better recommendation there, and then we can
go through the ones you got on Twitter.
Want to come on.
Yeah, go through the ones you got on Twitter first, and then in the meantime, if you want to ask a question, just request up to be a speaker so that I can add you up and get you ready. But yeah, until now, it'd be great to go through some questions that you have from Twitter.
Cool. Yeah, so the first one I found, I'm not sure, I'll message you these questions so that you can attach them to the chat so people can see it. So the first one is from John B. Any plan to have a smart contract language built on top so HyperSDK can be used for a generic all-purpose DeFi chain? If yes, which one? Example, Solidity, Cosmwasm, Move, other, question mark. I think that's a great question. Right now out of the box, the HyperSDK does not have general smart contract functionality built into it. So if you want to add an action, you actually have to add a specific action. You can't just like deploy something while the chain is running. And that is not from the perspective of, it has to be that way. It's more from the perspective of adding generic smart contracting to a new SDK the right way is complex. And I wanted to pursue more of a simple approach that just showed the core design ideas and then add that on later. And so, yes, we're very interested in adding, smart contract support to the Hyper SDK. And the way that we would do that would be that actions, when they're executed, can invoke arbitrary external modules that can run smart contracts. And so the example here I'll give is WASM. That's one we're most excited about and most actively investigating. And the idea would be that, if you call this particular action, we'll just call it like an invoke transaction or an invoke action. It will spin up a WASM runtime related to whatever like module or like whatever contract on chain you're invoking, and then it will just execute the transaction or execute against that state. And so just a reminder, right? Like normally to do all this well, you're going to have to implement syncing and all the stuff like that. But the Hyper SDK just handles this behind the scenes. So if you're interested in experimenting with just purely smart contract runtimes, it's a great way to hook it up. In terms of other ones, we'd be very open to seeing modules that fit in here in other languages. But I think that the primary focus will be on something new to the Avalanche ecosystem that we really haven't seen before. And that new thing, we hope to be WASM more so than Solidity or Move. Cosmwasm, I think, is a really good place to look at for inspiration, but it's pretty specifically focused on the Cosmos SDK. So we'd like to have a little bit more generic version of that. Great question. I see that, Kyle, you brought up a speaker. We'll start, we'll take a live question.
Yeah. Genheads NFTs, you're up first.
Hey, thank you very much for having me up here. Didn't even expect to be up here, to be honest. Shout outs to Avalanche. Basically, we're from the Zen community. Well, I'm from the Zen community, and we just really love what you guys are doing. And there's a lot of us that are super bullish on your chain, and with Zen being deployed on Avalanche. And we really just wanted to just say, keep doing the great stuff, to be honest. Don't really have a question, just more of a big up to Avalanche, shout outs to you guys.
Cool. Thanks for stopping by. I think you mentioned you do some NFT related stuff. The next virtual machine we release, the token virtual machine, which I think Kyle pinned up here on the top if you want to follow along, will let you mint arbitrary tokens and then trade them directly on chain. So if someone is interested in building like a cool experiment with that, it'd be a lot of fun, and the initial throughput results are looking pretty cool for that one because it basically modifies a lot less state for most transactions in the index VM. So if you're an NFT lover and interested in building your own like runtime just for minting NFTs, I think that'll be a really cool one to look into. But thanks for stopping by.
Yeah, thanks for
Feel
coming
like a radio
through.
host.
Yeah, for sure. Yeah. First time listener,
I'll take
caller.
one. I'll take.
Go for it.
Yeah, exactly. I'll take one more here. I'm linking it to you. This one is from GC. So not a question, but I think it'd be worthwhile to have a let's build a VM using HyperSDK YouTube tutorial series, either from the team or as part of a competition. Visual content to showcase how simple it is to use is, in my opinion, the best way to spread awareness. I could not agree more with this one. I can show you like little clips of documentation, little tidbits and everything like that. But seeing it live and seeing it come together and run live is such a different experience. And that's one of our primary goals really to get this thing off the ground is to showcase how it can be used. So that we can first of all find issues where we can improve it, as well as if you don't if you don't going to read like the paragraphs of documentation and just want to see it come together, that we'll help you do that. And so yeah, definitely, totally agree. Luigi volunteered to film all those videos, so you can pester him about that.
Yeah. All right. Good to know. But yes, I agree with that too. We're going to be putting out more visual content to help showcase a lot of this stuff. One other thing, Patrick, I think you mentioned this, but there's a Discord channel for HyperSDK. So if you go into the Avalanche Discord, there's a great channel in there where builders are starting to discuss what's possible, what people can collaborate on, and we'll also drop some any of the visual and explainer and demo type content in there as well. So,
Cool. Yeah,
looks like we don't have anybody
do you
else.
have another speaker, or I got another question I can take on too?
If someone pops up, we'll add them in. But for now, yeah, if you got another question from your thread, that'd be great.
Cool. Yeah, so I just dropped another one. This one's from Space Evader. Do the state keys on auth only get called by actions we implement? I've seen transaction malleability be a thing on other chains. Is that something we need to think about here with regard to TXID? Great question again. So this is a very loaded and interesting question. So this response may take a little bit longer. So first of all, do the state keys on auth only get called by actions we implement? So state keys, to back up something I haven't covered yet, one of the ways that HyperSDK gets so much performance out of your virtual machine is it forces you to make decisions that let it run your code fast. One of those decisions is that for every transaction, which is composed of an action and an auth, you need to tell it what sort of state keys are you going to use. So are you going to use, like let's say you're doing the transfer, right? I need the state key or like the key in the database that stores the balance of the sender and the balance of the recipient. So the way that this works though is if you specify state keys you don't use, that's totally okay. But if you try to access a key that you haven't specified, your transaction will fail and revert. And so when you're building your virtual machine or your blockchain runtime, it's important that you populate these correctly and that you populate hopefully what the minimal set is, because you don't want to prefetch state that you're not going to need, right? That's not going to be useful. And so what makes this super useful then is because every action and transaction knows exactly what state it's going to touch. You can now on the fly generate conflict sets and then have transaction parallelization just out of the box, right? Like if you are scoping transactions to only a specific set of keys, and then that specific set of keys is not going to conflict with someone else, you can run those entirely in parallel. And so this is something that we're going to add very shortly. We had it previously, removed it because the way that we were doing it was actually slower than just not doing it at all. So we have to rethink that a bit, but we have some clear ideas on how to do that. And at least the framework is well set up for that. Now, the question about transaction malleability with state specification is typically the case in UTXO-based chains where you're like referring to some set of UTXOs that you're modifying, or you have to reference keys in a trie, which may change based on different values that are added by other transactions. So that by the time your transaction gets executed, it may be referencing things that are completely unrelated. And so sometimes in systems like that, the virtual machine will like modify your transaction to make it valid in some very clear set of ways. The cool thing the HyperSDK does is that the state keys you provide are actually not tied to the trie. They're just the actual key where that item is stored in the database. So if you change the value of that key, it's still valid, which is really cool. So like if in the same block I send a transfer to you and then a transfer to someone else, and then maybe those get ordered in the wrong way, my original transaction would be invalid because the UTXO I'm trying to spend would no longer make sense. Well, my balance is always stored at the same key in my database. So if I reference that in both cases, it doesn't really matter. So we don't actually need to modify anything about the access list on the fly, which is also very different than other virtual machines that may reference state slots or reference things that change address as they're modified. So very good question. I know, Stephen, you've thought a lot about state management stuff. I'm not sure if there's anything you want to add to this particular point.
Yeah, I mean, I think touching back on the malleability part, I think some of that comes, and I'm going to pose this definitely as just a question to you, Patrick, because I'm sure you know better than me. But I think some of that question might be along the lines of like, if you have this like auth module, can someone add additional keys given like some pre-existing transaction such that it'll still pass the auth module? And so I guess my guess is that the answer is that the auth module can perform any number of verifications to enforce a canonical like setup so that this wouldn't work. But I don't know if you want to touch on that.
Yeah, you're fully in control of all the cryptographic verification that's and you also are provided state. So let's say that you had like a fancy authentication scheme in state that like said who was available to sign at a different time. You could have conditional verification or like conditional validity on whatever you in your auth based on what's changed. But then the cool thing is you can then also use any authentication scheme you want. So like if you want to use like quantum safe SIGs, like go ahead. If you want to use Edwards like we do, you can do that. Or if you just want to use SecP, you can also do that too. But the whole idea here is like outside of state, the biggest restriction with the HyperSDK is really this specification of state keys. And so if you're looking for things that like, wow, like why wouldn't you use a HyperSDK? That is just the one complexity. And for the people that we've talked to that want to build a virtual machine, like I said, that are so interested in performance, that's okay. Like they're willing to make whatever trade-off is required to push the envelope on performance. But in some applications where you may not know the state keys ahead of time, it can make it much more complicated. And so I think what will happen is we'll probably have a mode of the HyperSDK in the future that just ignores state keys and doesn't do that sort of verification. And then your chain will run a little slower, but you'll get everything else you need out of the box. So maybe for like different sort of smart contract invocations or something like that, may not be some burden you want to impose on your developers. And so you're willing to accept a lower throughput to make it easier to interact with. But this is just, a sampling of the, design space we're really interested in exploring. Hopefully that answers that particular question.
Cool. We have one more that just dropped up here, so we can add them up. So,
Cool.
Simple Waters, you were up next.
Hey guys, hope everyone's doing well. I'm a big fan of Avalanche, and yeah, just what you guys are doing. My question is I'm a big fan of a protocol that's been launched on 10 different chains. I'm not really shilling it, but it has launched on the Avalanche chain, and I've been really bullish on it. And I just had a question for you guys, just on throughput. There hasn't really been too much, so to speak, testing on Avalanche chain, just as far as the community that I'm part of. It's called the Zen community, and Zen was launched recently. Their Zen NFTs were launched on the Polygon chain, and it actually crashed their network. A lot of it just because of the gas settings that Polygon has in their protocol. I do believe that Zen will be launched on Avalanche coming up here in the next, I would say, maybe month. Hopefully that's bullish on that month. But when it comes down to a stress test, where do you guys feel like has there really been something that stress tests your guys' C chain? And forgive me for my ignorance if that's a silly question, but yeah.
Yes, I mean, I think this is a really interesting question that I think covers a number of different things. And this is, again, I think, like network design philosophy, which is what is the target stress you are trying to put the network under, and like what is the minimum supported hardware requirement for compatibility. So on Avalanche, the primary network, the goal is really to have as large of a validator set as possible and to make the primary network run at a level that is at a certain point, such that if you're running different subnets, you can still run really, complex and performant subnets without burning the entire network, right? Like, let's just say, I'll give a very specific example. Let's say that the C chain, we were trying to run at a target of 100 million gas per 10 seconds. That's higher than Ethereum, higher than any other EVM chain as far as I'm aware. Such that when you were syncing just Avalanche, the primary network, you had to run it on like some sort of supercomputer with some like crazy disks to handle that. And then I with a straight face told you, cool, now that you're running that, can you also run this other like super high performance virtual machine? The answer would be no, right? Like you kind of have to make a choice. And so we have found that like the right way to balance that trade-off is to purposely limit the throughput and activity on the Avalanche primary network and to push applications that have higher throughput to subnets. Now,
I'm sorry.
let me finish that point, and then I'll definitely turn it back to you to see if I feel like you've answered my question. Now, the complexity with that is then, well, the C chains where most of the people are, right? So if you're trying to launch a project or launch an application, you don't want to post on an island no matter how performant it is, right? Especially with an NFT project. And so a lot of our current research is going into how do we better connect the C chain and subnets so that you can more easily like kind of move value and move data between the two so that you could actually do your high throughput thing on your own subnet with optimized virtual machine and optimized hardware. And then only if needed, bring back different components of that high throughput activity back to the primary network. In the meantime, Dexalot, which is a different ecosystem project, has really experimented with this, and they do a lot of their high throughput trading on a subnet, and then keep all the assets still on the primary network. So then they reference back and forth using layer 0 as like kind of the data transport layer. So the answer to you quickly is, the throughput targeted on the primary network is going to be lower than some other EVM chains, and that's purposeful because the subnets are really the scaling mechanism here. We are not trying to have the primary network be some super expensive thing to participate in. We're trying to minimize it. But if you want to run different sort of simulations on your own private network, we actually have a simulator module that's included in the subnet EVM that you can use to actually run arbitrary simulations on your own subnet, which a lot of subnet providers have used to test out different gas settings, basically, to see how DOSable they are, anything like that. We've also been told that actually other people, other networks, also use the simulator to test it out because it's EVM generic, so you might as well just use it. So let me pull that up for you real quick, and I can share that with. Here we go.
Awesome.
I'll share that with Kyle now to drop in. But yeah, so I mean, long story short, you know, the C chain is meant to be at a point where you should increase, like the gas price should increase before you hit any place where the chain will crash, per se, if you've had that experience with other chains.
Yeah, and I guess just one of the questions, and I'm totally getting what you're putting down there. So I guess my question is so the C chain is not considered a subnet, right?
No, the C chain is not considered a subnet.
Okay,
that's correct.
And so
that, very briefly though, people have discussed doing that and moving it to its own subnet so that we could increase the throughput. But that introduces a ton of different complexities related to like fee payment tokens, shared security and stuff like that. But people have, sorry to interrupt you, but have tossed the idea around. But currently, no, it's not.
Yeah, and that's just wild for my my personal participation in a protocol that has been launched on the CNET C chain on Avalanche, and there's not too many users there. I think there's probably about a little bit over 1 million, but and that's probably within the last 100 and some odd days, so it's relatively new. But I will say that the next thing that's going to be happening, and again, I'm just speaking of the project I'm involved in, but I'm just pumped about it because it's Avalanche. It's going to be hosting it. The Zen NFTs are going to be launched on Avalanche at some point soon, and I guess I'm just I'm interested in that whole stress test aspect because currently the offering is on the C chain, and the whole subnets. I don't know if that's actually going to be something that the developer is going to be developing on, because we kind of want to keep it all congruent to the coin offering on C chain. So yeah, I guess we'll just have to see, and hopefully we can revisit this conversation once that's done. Hopefully that your guys' network doesn't go down and is able to handle the throughput that's going on.
Yeah, I'm so just to touch a little bit on like the economics at play for like how this works is essentially there is a continuous auction for people trying to buy the basically the throughput of the C chain. And so the actual like load on the C chain is pretty well capped by just a number in the code base. So if you go to like, the Ethereum mainnet or any of these kind of like other like EVM compatible things, same with the C chain, there's basically just a number in the code base that says how hot it can run. And how big that number is how kind of responsible that network is. And so we align pretty closely to mainnet Ethereum for that number. And so at the end of the day, it's not really so much of a how hot is the C chain going to run. It's like how much would someone be willing to pay for the that load on the network, right? So the amount of load is going to be the same. It's just whether people are bidding a higher or lower value for it. I would just be careful not to bid against yourself.
Yeah, so I mean, and then to parlay this back into the HyperSDK, right? As a virtual machine designer, the HyperSDK lets you specify exactly how fees are paid. Every aspect of it. You want to pay your own token? Do you want to pay other people's tokens? Like based on how the actual virtual machine is designed. And you as the developer have to pick fee parameters that are responsible. Meaning that like if someone was persistent and tried to bring down your network by sending a ton of transactions that took your node a while to process, would your node fall apart? Or like, would the subnet halt? Or like, would you have major issues? So your concern about like what could happen in this network is very relevant. And I think it's very relevant to also people that are using the Hyper VM, because at some point you have to specify, hey, this like, native on-chain trade, does that cost a fraction of a cent, or does that cost $100? Well, it really depends on what you're doing behind the scenes and then how complex that is for your node to process. And so adding a simulation suite into the Hyper SDK is also something to be really important to us. But on a regular basis, we really hope to start publishing benchmarks, or what we call nightly benchmarks, of different performance concerns in the Hyper SDK. So you can have more information about how you should charge different fees to make sure that things stay safe, and basically that the fees go up instead of the network going down, I guess is the way I would describe that particular concern.
Yeah,
but thank you for the question.
Yeah, I really appreciate you guys answering that. And yeah, I mean, I'm sure this is one of the first spaces that I've tapped into with Avalanche. I'm glad that you guys host it. And yeah, just I would say be on the lookout for some waves, so to speak, with the Zen community heading over to Avalanche. So we definitely love what you guys do. And one last question before I drop down to listener, and I'm sure you guys have kicked this idea around a bunch, but just with the whole AWS with Amazon speak, as well as I'm sure other organizations and companies kind of looking at Avalanche as another option to kind of veer away from the OG Ethereum. What are you guys kind of seeing on the forefront when it comes to Amazon kind of integrating and helping you guys build out your chain offering, if anything, that you can speak on? Thanks.
Yes, I mean, so first off, to back up, right? Like the hope with the Hyper SDK and different SDKs on Avalanche is that they become so generic and so capable that you don't have to run like traditional server architecture to like ensure business. That's really what this all comes down to. And for Avalanche to have that sort of generality with different runtimes and different things like that is a way to look at it as a place to launch projects that are very crypto native and very, really just modern, and they don't use a single backend or single database to store everything. However, we're not quite there yet. And so for a lot of businesses that are building, on different blockchains and applications, especially if they're new to crypto, want to use service providers that they trust. Yeah, like most new modern startups and tech companies use AWS. People also use Azure and Google Cloud and everything like that. Is that because that they're like super against decentralized compute, or like against the idea that of the cloud in general? No, it's just because they're trying to make it as a business, and AWS makes it easier for them to do so. And so the feedback we got, we always listened to like the community and what people are doing was, hey, like love the idea of using Avalanche and doing different things on it, but I really want to work with people I already know how to work with. Like I already use Amazon's tools. I already, run servers in AWS. Can I just run your stuff there too? And the answer is yes, but you got to do some manual stuff and, everything to make it work well. Well, by partnering directly with AWS, we can help make that even easier. And they're very interested as well, because a lot of their clients ask them the same thing, right? So like we have Deloitte runs a subnet on Avalanche. Deloitte is not necessarily interested, and I don't know what their interests are, just to caveat this, right, in running like some super crypto native, crazy server thing to like for all their corporate clients, right? They want to run probably in some gov cloud that has certain restrictions on it, and they would just want to run an Avalanche node there, right? Well, if we can make that a one-click thing on AWS, that makes it a lot easier to get involved. And I think with subnets and like the flexibility with them, directly working with different cloud providers or different places really where people already are just makes it that much easier and more powerful to use subnets, right? Like, so one thing in the Hyper SDK that's really cool is the storage backend is fully generic. So, most blockchains will store everything on the disk of the node. Well, because the storage backend is generic, you could just swap that out for like a SQL database on AWS if you wanted to. And that AWS database could then be used to do analytics, could be used to do everything, and then your node could just focus on validating the chain, which allows it to run at higher throughput. So hopefully that answers your question. Yeah.
Yeah, definitely,
Awesome.
definitely. Thank you.
Thanks, man. Yeah, I appreciate you coming up and lots of great questions there. And Patrick, thanks for breaking it all down there. So yeah, we're at time. It was really great to get all these questions from the audience here, and I'm sure there's going to be a lot more discussions around HyperSDK, both on Spaces and through the content that we put out through all these different channels. So yeah, make sure to drop in the Discord channel. Follow Patrick on his HyperSDK journal as he takes us through a lot of the stuff that's being built. So yeah, final words, Patrick, Steven, if you guys want to share anything at the end here, and then we'll let everybody go.
Avalanche.
Yeah, just thanks for having me. Looking forward to keep seeing what Patrick puts out on the HyperSDK journal, and yeah, if we keep asking him to, maybe Patrick will eventually become a Twitch streamer, just live coding his stuff.
Yeah, no, hopefully not. But thanks everyone for listening. I think SDKs are really a function of the community that puts them together. One person, one team cannot really showcase an SDK on its own. And it's really important that that there's a dedicated group of people interested in evolving it and seeing it through. And so really looking forward to engaging with people that are interested in doing that and really evolving this SDK to get to a place where it's really useful for just about everybody. But we'll see where we go. Thanks, Kyle.
Amazing. Yeah. Thank you both for walking us through that. Excited to see what's to come and excited to see what the community collaborates on. So exciting projects ahead. Thank you all for joining. Stay tuned for the next Spaces. We got one tomorrow, 10 Eastern, with Loco, talking about what they're building on the Avalanche subnet, bringing fantasy sports and games to Avalanche. So excited for that. So we'll see you all next time. Take care.